Hey everybody, this is problem 4 on the summer assignment about the freshman that's lost at Hillsborough High. So we're told that they take 3 steps here. And the first step is right here, that they go 262 feet to the north. So that's right there. The second step, they go 473 feet to the east. And the third one, it says 308 feet, 76 degrees south of east. So that means they're going east and south. They're at east and then a lot south, because that's 76 degrees, all the way down there. And what we have is a little I and a little F. Part A says, on the map to the right, draw one vector that represents the total displacement of the student from their initial position to their final position. So I'll do that. I'll change up the color of this one. Let's make it green. Good. So they're going to go from this initial point to this final point. And that green vector right there is the angle, is the vector that they're traveling. It shows where they started, where they ended, and the direction that they went. So that's that. Draw the vector that shows how they got, or where they actually changed their position from. Part B says, okay, let's figure out the magnitude and the direction of that displacement vector. How big is that? Well, if I'm going to do that, I'm really going to need to know, let me go back here, change up the color here. I'm going to need to know how far the student went north, how far the student went east, and then how far the student went south and east on those 3 steps. So at their beginning, at that little I, the first thing that happened was 262 feet to the north. Then it was 473 feet to the east. And then down here, that overall is 308 feet, 76 degrees south of east. So when we say 76 degrees south of east, it means this little angle right here that goes south of east is 76 degrees. And this one is 308 feet. So what makes this tricky is that 308 feet at that angle. What would actually be easier is, instead of talking about 308 feet at that angle, is if I knew how far south and how far east that was. I can do a little separate problem up here that breaks that up and shows us exactly what that would be. So here's my little triangle. And this triangle is 76 degrees and then 308 feet. If I think about that like the hypotenuse of a triangle, I can say, oh, that's 308 feet at an angle of 76 degrees. This side over here must be 308 feet multiplied by the sine of 76 degrees. It's the opposite side of that angle. So 308 sine 76 degrees. That is 100, I'm in radians. That 100 made no sense. That's 299 feet. The horizontal side must be 74.5 feet. And that comes because this is the adjacent side to this angle. So that must be the hypotenuse multiplied by the cosine of 76 degrees. So what we figured out is that in that last step, the student moved 74.5 feet to the east and 299 feet south. Those directions are key because now we can realize we know the total amount that the student moved to the east. The student must have moved 473 feet to the east and then another 74.5 feet to the east as a result of moving east on this triangle. So the total amount to the east is just those two added together. 473 plus 74.5. And that's 547.5 feet. What we also see is that the student went 262 feet to the north and then 299 feet south. That means the amount that they went south must be 37 feet. Because they moved a little farther south than they did north. It's 299 feet south, but only 262 feet north. So overall, we see them shift down a bit, which matches what's happening on our picture. So if I scroll down a bit, I can now look at this vector and say, okay, overall, this must be 547.5 feet to the east and 37 feet south. So the overall dimensions of this, the hypotenuse of this, and I'm just using the Pythagorean theorem to get what that is, 540, we'll call that 549 feet. And then this angle, a little trigonometry, is 3.9 degrees. So again, Pythagorean theorem to get this vector, and then this angle, I could realize that the inverse tangent of my opposite over my adjacent is equal to this angle. And there we are, 549 feet, and then 3.9 degrees south of east. And everything really came from up here, realizing that that third step, it was easier to discuss that in terms of how far to the south that was and how far east it was, because the student walked real far south and a little bit extra to the east. So to figure out the overall dimensions, you look at step 1, step 2, and then the 2 steps that kind of make up step 3 to end up with this one. But there we go. That's that problem. Thanks.